Okay, so the biggest thing here is, the code we're writing has become pretty complex. And I mean, not crazy bad. We're doing everything we can to take the complexity and program in such a way to make it as not complex as it can be. But our programs and the code that we're writing is becoming sophisticated enough that the assert tests that we've been using are limited. They're not going to be providing the breadth and the capabilities of testing that we want to really do a good job testing. So we're going to transition to using something called unit test. Programming languages all have their own variations of unit testing and how you do it. There's different frameworks and whatnot, but they all follow the same general idea. We're using Python's unit test here. And the reason I waited this long to show you unit test is there's quite a bit we needed to know in order for this to make a lot of sense to you. That said, there's still going to be stuff in here that's not going to be immediately clear, but that's not that big of a deal at this stage. The bulk of what you need to know, you know, in order for this to work well. When writing unit tests, the spirit of what you're doing is the same as what you've been doing with the simpler assert tests. You want to write these single purpose tests to test something. All right, so in order to start writing a unit test class, we do this. There. Nope, pass. There. Now it'll be happy. It looks like this is actually going to assume we have the sphere class written. So, for better or worse, it looks like I'm going to have to go back and write the sphere class, which also means we're going to have to go add the point3D class. So let's do that real quick. Nope. So this was the point3D class. You should hopefully remember. And we did the EQ and repr. Nope. EQ repr. Good, that looks pretty good. So there's the point3D class, and now the sphere class. Okay, it looks like I've got it. All right, let's do a quick check by trying to just make an instance of a sphere. So oh, did I not include the, it looks like I skipped the repr EQ for a sphere, yeah. think I was saying last time, but I'll say it again just in case. When there's a lot of magic methods, these are like the double underscore ones. There's a lot that exist. And you only implement them if you need them, but you almost always implement your EQ and your repr though. Those you implement. And then if you want to define what it means for one sphere to be less than another sphere, then you go and implement the magic method. I think it's underscore underscore LT underscore underscore for less than. But here, that doesn't really make a lot of sense, so we leave it alone. All right, great. So we've got our point 3D and our sphere class there. Great. So let's go back to unit tests. All right, so here's how we start. We start by importing unit test. That's the thing we're going to use. And then we create a new class. And the class is going to contain our unit tests. We say class sphere test. But then we see something we haven't really seen before. We've got parentheses next to the class name. And in the parentheses, it says unit test.test case. Without getting too far into the woods, this is to say we're making a series of test cases, but a specialized version of them called sphere tests. Okay? So they're test cases, but they're a specialized version. That's kind of what that means, without getting into the details there. There is a convention to follow when naming your test classes. You name it the name of the class that you want to test, followed by the word test in camel case. So this is sphere test. If I was writing one for point 3D, it would be point 3D test. That's the convention you're going to follow. And then after that, it's just a class. But we're not going to write an init. We're not going to write an EQ. We're not going to write a repr. No, this is a very specialized class for unit testing. We also notice, in parentheses, the nuance means outside the scope of the course, but in short, we need to know, whatever. So writing unit tests. I'm just going to copy these in and we'll talk about them. There. Now, each unit test that we write is going to be a method that belongs to this class. Meaning, and most of the time they're not going to have any parameters other than the self, because it's a method. So here we say def test sphere center point returns correct point 3D. What do you think that test tests? Without even looking at the code, the name of the method is going to tell you what it's going to test. And we want our method names to be as descriptive as possible. You might look at that and be like, that's hilariously long. Yes, because it's descriptive, and that's the point. Because when I run these unit tests, and it says, unit test, test sphere center point returns correct point 3D failed, I know exactly what went wrong. So this is like assigning a name to what that assert test you were doing was doing. You've given it a name, suddenly it's more descriptive. And another thing too is your test methods must start with the word test. I think there's a way around it where you don't actually have to if you go tinker and change some funny settings. Don't do that. Just make your method start with the word test. So test, sphere center point returns correct point 3D. And all this test is going to do is test one unit of functionality. So what do we have? We create a sphere, some arbitrary values, and then I say self.assert equal point 3D, that is to the sphere.centerPoint. That's how I'm checking the equality. Now this requires that point 3D has the equal method, like the underscore underscore EQ underscore underscore method implemented, which we did. Because when you check equality with these assert tests it needs to have the equality defined for it. But there we go. This I would write as an assert test very similarly. I would create the instance, and then I would just say, okay, point 3D 321 equals sphere.center point, like assert that, fine. But now I'm doing it in a unit test. Next I have test sphere radius returns correct radius. Create a sphere, you give it 11, and then after you've created it, make sure that the radius of that sphere is 11. If it is, chances are that stuff is working correctly. Any questions so far? You might think there's a lot of boilerplate code here just for a simple test. And yeah, you're right. That's the way it is. But with this, you get a lot. This is a good thing. All right. So the above two tests confirming the correctness of the constructor and the assigning of the sphere's class attributes. Things to note here. The test methods that belong to the test are methods that belong to the class. Each method's parameter list is just self. This isn't always the case. It is possible to have tests that take parameters. We'll learn about that later. Actually, I'm not sure if we learn about it in this course. It doesn't matter right now. And each method starts with the name test underscore. The method names are descriptive, so it's easy to know what it is. And the test prefix is required, but after test, the name doesn't matter. So the fact that this is called test underscore is important. Everything after the underscore, at the first underscore, doesn't really matter other than being as descriptive as possible. If you look at this and you're like, but that's a hilarious long method name. Yes, it is. That's very much on purpose. And we're making use of assert equal, which is a method referenced by the self-reference variable. Although we did not write this method, we inherited it, whatever. So when I say self.assert equals, when I say self.method name, that means that that method actually belongs to this class, this instance of this class. But you'll notice there is no assert equal method in this class. Well, it's in this class. It's in there. In fact, I wonder if we could actually go find it. It might be hidden in some other deeper spot. Oh, come on. What? Why won't it let me? All right, I give up. Anyways, we got it for free from this class. We inherited it from this class. The method provides a simple mechanism for setup code. Yeah, so what's nice here is the setup code and the test is grouped together. Where before, when we had just that long list of assert tests, we made one at the beginning, everything got jumbled. It was hard to keep track. No, look, each test is its own nice method. It's easy to look at, to know what it's doing. The setup code is there. Everything's nice, self-contained. Each test is self-contained. That's very good. We like that. And each test, this is a mistake a lot of new programmers make. Each test should test one thing, only one thing. If you have a chunk of code that has like 2 impacts, you write 2 tests. You don't write one test that asserts both things being the case. No. You could do that, but that's bad design. What you do is you write one test and you confirm the one thing, and then you write another test and you confirm the other thing. And the reason we like that is when your test fails, you want to know which one failed. You don't want to know, well, one of those 2 failed. No. If one worked and this one failed, good, I now know where the issue is. If I wrote one test with a bunch of asserts inside of it and it says test failed, I go like, well, it could be any of those things. That's a problem. And then other than those points, so far, there's really not that much difference than the spirit of what we've been doing before with our assert tests. It really is the same, it's just the syntax is quite different now. But the idea, the spirit of what we want to achieve with the testing is the same. So let's add a bunch more tests here. Test equals on equal spheres returns true. Create two spheres that are equivalent, assert that they're equal. Test equals on not equal spheres returns false. Okay, do it. Test equal on sphere and string returns false. So basically checking if things of different types. Test repr, arbitrary sphere returns correct string. Great. You might be saying, well, you checked equality on these spheres, but what if like different values, or you checked inequality on these spheres, but what if you just kept changing all these different variations? You could do that. I mean, it's the same thing as the assert tests, right? Like, well, what if these attributes are the same, but this one's different? And then what if this one's different and these ones are the same? And what if these ones are different and this one's the same? You can do every possible combination, but you got to draw the line somewhere. So don't go don't go too crazy with checking all the different variations of a single case. There's ways that you can kind of lump several cases together in a single unit test, but we'll see that later. All right, the above are additional tests for the magic methods EQ and repr. For two of the EQ methods, we will use setup code is a little bit more involved. Really, it's just I created two spheres. So when I say a little bit more involved, I mean just one more line of code, fine. But I still needed it. In order to check the equality between two spheres that are the same, I needed to make two spheres. To check the equality on spheres that aren't the same, I need to make two spheres. So that setup code is grouped together with that single test. I realize there's some redundancy between the two tests, but that's okay. If all of your code required the same setup code, there's a way to deal with that, but that's not really the case here. Or pardon me, what I meant to say was if all of your tests require the same setup code, yeah, there's a way to do that, but that's really not what's happening here. And look, I didn't use assert equals, I used assert not equal to check those things. In fact, let's have a quick look. There's a lot in here. Assert almost equal, assert count equal, assert dict contains subset, assert dict equal, assert equals, assert false, assert greater, assert in, is not, less. There's a lot. You would choose the one that's most appropriate, right? There's like an assert true, for example. Maybe you have some function or method that returns a Boolean and you want to confirm that it asserts true, so you would use this. You might say, well, why not say the thing is equal to true? You could do that, but there's a more appropriate method to use. There's an assert true. Anyways. Although all the test methods start with test, as conventions consistency readability, the method names follow a pattern. Yes, here's another thing too. So it's required that your tests methods start with the word test underscore. That's required. But there is a good convention to follow when writing your tests. It should be test, method, condition, expectation. So for example, test equals on equal spheres returns true. See how it's the idea of, okay, test. I'm testing the equals method. On the condition, equal spheres. And what I expect is returns true. That's the pattern that I am going to require that you follow. It's a good pattern to have. And if you're consistent, it makes reading your method names way easier and everything. It's great. So the method equals unequal spheres, return true. If you were to, now, to be clear, if you wrote a test saying like test equals spheres true, yeah, that's fine, right? It's just, to me, this is a little bit more Englishy, which is nice. Because remember, code isn't for computers, it's for humans. Compiled code, zeros and ones, is for computers. So I just liked it a little bit better. Any questions so far? To be clear, I haven't shown you how to run these yet. I just showed you how to write them. With the assert tests, you would just hit run, and when everything passed, you wouldn't see anything. If there was an issue, it would fail. These are going to work a little differently, but anyways. So, it's not uncommon for situations where, okay, look, I want to test the diameter method, but I don't really want to just test it once. And I could write like, maybe I want to test it like 3 times. Test it where the diameter is 0, or when the radius is 0, when the radius is like 1, and the radius is like 1,000,000, or what happens if the radius is like -7, right? Like maybe there's a couple of cases I want to test. Now, I just made a big to-do about write a single unit test, write a method, one method for each of the things you want to test. But here's where it's funny, because, well, my test, I could do that, but really the spirit of the test is, does the diameter method work? My test would be like, test diameter, arbitrary inputs, returns correct diameter, right? But what are the arbitrary inputs? Well, we can use something called subtest, which basically is like writing a loop with an assert, and it loops through each of the different cases. And I'll show you what I mean, and I'll come back to explain a very important thing. So I'm showing you, okay, test diameter, radius 0, origin returns 0, test diameter, radius 1, origin returns 2, test diameter, radius 0, arbitrary center point returns 0, test diameter, radius 10, arbitrary center point returns 20. So here I have 4 separate unit tests, and there's nothing wrong with this. But what we can do is this. I create a list called cases. I mean, whatever I call this list doesn't really matter. I just think cases is a good name. And in it, I have 4 different spheres I'm creating. And I'm creating a corresponding list called expected that contains the expected diameter respectively. So I expect to get 0 back, I expect to get 2 back on the next one, I expect to get 0 back, and then I expect to get 20.2 back, right? So far, so good? And then, for case, I've never shown you this before. This is a fancy way to say, I want to loop over 2 things, 2 separate lists, and I want you to give me the first thing from each list for the first run, then the next thing from each list from the next run, and so on and so on and so on. So that's what zip does, is think if I've got 2 separate lists, I've zipped them together, and then loop over both lists where you give me one thing from each at a time. Is that all right? It's pretty neat. I think it's cool. I didn't have to do it this way. I could have done it with just indexing the lists, but whatever. And then I've got case expected, and then I use with self.subtest, self assert almost equal, expect, and then case.diameter, where case is the individual sphere. I call the diameter method, and then I'm checking that what I'm expecting is what I get on each case. First thing I'll mention here is assert almost equal. Remember how comparing floating point numbers is a pain in the ass? Well, assert almost equal is like telling Python, look, just make sure they're close enough. Now here, there's actually a third argument I gave this right here. I gave it the expected, I gave it, the result of case.diameter. And then there's a 5 at the end. I didn't really need the 5, I probably could have not included it. But the 5 is like, how precise? How many decimal values is allowed to be different? That's what the 5 means. I probably didn't need to include it here, it's there. So okay, and here's the other thing I'm going to say. You might look in this and say, well, what's the point of the subtest thing? Just loop over each thing and do an assert, say self.assert almost equal for, let me show you what I mean. Yeah. There. I could just do this without that with subtest. I could just do this. For each case and expected, run that assert test. But the problem with doing it this way is if the first test fails, the whole unit test fails. But it might be the case that of those 4, maybe only 1 would fail. But by doing it this way, it'll say fail. If I do it with subtest, what Python will do here, what the unit testing framework will do in this particular situation, is treat these as if they are separate tests. Meaning, if the first test failed, it's fine. It's going to remember that it failed, but it'll still run the other 3. So that's the value of subtest here. I want to be clear about something too. When I'm lecturing right now about subtests and what, I'm not expecting you to be like, okay, I'll use subtests. I definitely know that. No. I'm telling you now so you get a familiarity with it. I've got the course notes. You could go find the documentation for Python's unit test and learn anything and everything you want to know about it. But when you need to write unit tests, you've got a point of reference, which is this lecture, and then you go look up what you actually need then. Whenever a student, here's the best, some of the best advice I can give you. Raise your hand if you're in first year right now. Okay, here's some really good advice I can give you. Never go to your prof ever, or complain, you can complain about your profs, fine, but never go to your prof and say, well, you never taught us how to do this. The prof's going to say, then go figure it out. You can do that. You are capable of figuring it out. So if you're saying you never really went into detail a subtest, you're right, I didn't. But you can do it. Because remember, who's your teacher? Everyone point at themselves. I don't teach you shit. Best I can do is facilitate. The rest is up to you. That's all to say, the point of this lecture is to give you a point of reference for this, so you're aware of what you need to know when you want to do it. That's the point. All right? Any questions so far, though? All right. Yeah, so here's like a general pattern of using it that I usually have. I'll have like cases, expecteds, and then for I and range and the length of the cases with self. Here I'm not using zip, I'm just indexing. I would say case at index 1 and expected at index 1. Ooh, I actually have this backwards. This is a mistake. This is a mistake. I got to go fix this. I want them reversed, but anyways, same idea. Now running the unit tests. running the unit tests because of Colab is a little weird. I'm going to warn you. It's easy to do, but it's atypical. If you were writing Python code and running your code on your computers locally, it would be done a little differently, a little more naturally, I would say, arguably. But when you want to run it on Colab, you got to basically use this magic line of code. Okay. Nope, what went wrong? There. And look, I get some output now about my tests. Before, with your assert tests, you didn't really get output. You only got output when they failed, and they would yell at you and be like, assertion failed, assertion error, right? Well, now I actually get some nice stuff. Oh, 7 tests ran, and it told me all the tests that ran, everything's okay, great, cool. That's awesome. Now, let's go back here, and I'm going to change one of these tests. Now, to be clear, this test is going to fail, not because there's an issue with the code or the circle class, but because there was an issue with the test. I made my test wrong now. I said, oh, I'm expecting to get a value that really is not what I should be getting. I'm doing this to show you what you would see if tests fail. So that one will have fail. These should not be equal. We'll make them equal. And this will make fail as, oops, will this make this fail as well. All right, so I go down here and I hit run, and we see, okay, look, I've got, okay, we see the first one, okay, fail, looks like something funny, and then, okay, so it's telling me fail, and it's telling me a little bit more information about why it failed. Assert test would just say failed. Let's look at what it's saying. So, which one's this? Test diameter, various spheres, returns correct diameter. All right, well, let's see what happens. Failed line 41 in assert almost equal, expected case diameter 5, assertion error. 0.1 is not equal to 0 within 5 decimal places. In fact, it's off by 0.1. Look at that. That's way more helpful than just assertion error. It's telling you what you were expecting, what I got, and here it's even telling me the difference between the two. How far off was I? What else? Test equals on not equal spheres returns false. Well, let's see. On assert not equals, assertion error, sphere blah, 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 radius. Well, this one's pretty obvious. They were equal. And then here, test sphere center point returns correct point 3D. Well, point 3D 32111 does not equal point 3D 321. So we get confirmation that the tests passed by being like, ran test, okay, okay, okay. It tells us tests fail, and unlike before, if I had a series of 10 tests and the first one failed, none of the other tests ran, right? Now, they're all going to run, and it's going to tell you which ones passed and which ones failed. And if they fail, it gives you some actual feedback. I realize with the assert tests, if the assertion error failed, well, you could do more digging by like printing out the result and what you expected and whatnot and check yourself, fine. But this is doing it for you. Way better, way better. Those assert tests, the only thing good about them is how simple they were to write. They really don't give you any bells and whistles like this does. This gives you so much. So look, 3 failures. Great. Ran 7 tests, 3 failed. Cool. Let's go back and fix them. I think that's them. Perfect. They all passed again. This here, I believe you can say how verbose you want the output to be. 3, well, it's probably not going to be very much. There. Here, I set its verbosity to 1. All it shows is me a dot. I bet you there's 7. 1, 2, 3, 4, 5, 6, 7. Yeah, cool. So there are some settings you can play with, but in general, this is what you're going to want here. And when you're like, how am I supposed to remember that? You're not. You go to this web page and you copy this and you paste this every time you want to run your unit tests. So don't worry about that. Yeah. So here I've got 12 tests. I guess some of these I didn't include in the above example. But there we go. Here's an example of output running 12 tests. I think, what did I say here? If a test failed, you would see something like below. Well, one of them failed, and it's saying test distance between center, various centers returns correct distance. Right? And it's telling me, well, assertion error, 1.732051 does not equal 1.4142135, et cetera, et cetera. And there's the difference. So these unit tests are way better. And if you think to yourself, man, that looks complicated to write. No. The pattern is hilariously simple. It looks complicated because you haven't done it yet. Once you do it twice, you'll realize, oh, this is a joke. Like anything, it just takes some practice. Before, whenever you wrote any code, you wrote your assert test, which of course you've always been doing. Now, no more assert tests, you write unit tests whenever you write code. These unit tests, this is what we throw at your assignments for marking. I've got a lot of unit tests written. And then when we mark your assignment, we just run the unit tests on your assignment. And it tells us what worked, what didn't work. It's great. All right. So yeah, you will see the output from the test is a lot more helpful than the assert test. It's telling you which test failed. It tells you which subtest failed. It tells us what was expected. It tells you what it actually got. And just because a test failed, all the other tests still ran. Typically, of course, unless you really mess something up, but whatever. Writing and running these might seem like a lot of work. It's not, though. Even more. Writing code, I don't care if you write code. I care if you write code that's correct. And the only way anyone is going to be convinced that your code is correct is if you give me code and you're like, is this right? I don't want to look at your code. Give me tests that run and pass, and now I'll look at your code. Because if you ran tests for your code and they all pass, chances are it's fine. Assuming you wrote decent tests. And again, I know you're all new programmers, so you're learning how to write tests as well still. I get that. But it's not it's no one else's job to confirm if your code is correct in general. It's your job to do it. Writing code is not what's expected of you. It's writing correct code. That's what's expected. Correct code that's good quality. That's well designed, of course, as well. But writing the code is only part of the job. Demonstrating that your code is correct to yourself and anyone else that might have a look at it is the other big part of writing code there. Usually, when software engineers are working together, they'll use something like GitHub, right? Like where the website's kind of managed. And it's a system for version controlling and storing your code base and everything, right? And it's nice and controlled. And whenever I want to make a change to the code, let's say I want to add a new function to the code. So I go write my new function, and I submit it. And before anyone else, before my changes, before that new function I write gets added to the code, it has to go through a review. This is how it works. It's got to go through a review. And the review is you submit it, and then someone sees, oh, there's some code I need to review, and I'm going to go look at it, and I'm going to look at your code. But if I look at your code, if I'm a programmer, if I'm a software engineer, and I look at your code, and you didn't write unit tests for the function you just wrote, I immediately reject it. Immediately. I won't spend a second more on what you did. I don't care if you say, well, can I have some feedback? No, test it first. No one's looking at this. No one will look at your code unless there's unit tests. I'm not telling you this for me. This is what you're learning here. You write the code, you write the tests. That's it. Any questions? So like here, look. You can go to the test folder on the GitHub repo. Every line of code, of like the code that you see, this is the GitHub repo, right here, has been tested. There's unit tests for everything. Like look, there's unit tests for like the loop topic. I wrote unit tests for everything in the loop topic to make sure that the code I gave you was correct. You always write your tests, always. If someone ever tells you you don't need them, you should not be listening to that person. That is really bad advice. That is detrimental to you. Anyways. Any questions at all? All right, no sense starting the next topic, so we'll end here. I'll see you all later.